This talk is an overview of Irsa, the NASA IPAC Infrared Science Archive. First, before I tell you about Irsa, I probably need to introduce the concept of astronomical archives. It is really true that there are more data than professional astronomers can hope to completely mine, and more is coming in all the time. It is certainly true that professional astronomers are going to pull off the low-hanging fruit, but that doesn't mean that there's not tons of discoveries in those archives waiting to be found. Any facility that comes from public funding is supposed to have a publicly accessible archive. These are your data too. NASA is really, really good about this. NSF is getting there. Europe is catching up. Other countries like China, not so much, but they're getting there. NASA data alone will keep you very busy for quite a while. NASA data sort of comes in three flavors. Astronomical data, in other words, things outside our solar system. Moon and planetary data, things in our solar system. And then, of course, tons of Earth observing data. I know the least about Earth observing data, and I know very little about moon and planetary data because I'm an astronomer. And so I focus on the astronomical data, therefore, so will the rest of this talk. But I wanted to highlight the fact that there's tons of moon and planetary data out there. And in particular, Emily Lakdawala at the Planetary Society is a huge supporter of and advocate for a community of so-called amateurs that do marvelous things with this planetary data. And she has many tutorials on how to get access to and work with those images. But again, I'm going to focus on the astronomical data. So the archives are designed for the professional astronomy community. So what does that mean? Well, you may have some sense of the difficulty in designing an archive if you have ever tried to organize your own photos. Because you may have photos from your cell phone and maybe your prior cell phone and maybe an SLR camera and then maybe the phones of other people in your household. Have you downloaded them all? Have you sorted them? Do they go with a different file naming structure? Wait, you just dropped your phone in the parking lot and it skidded across the pavement and shattered. Did you download that before you lost the data? What about if you want to find a particular photo from a particular event? I live in Southern California, so remembering that I didn't bring a jacket is not helpful for identifying even what season I should be looking in to find a given picture. So astronomy archives need to be easily accessible so that you can find by position on the sky, by time, by wavelength, by instrument, by telescope, so that you can access all this data. And because those archives need to be designed to be easily accessible, if the archive team has done its job, then you too should be able to get into it without too much trouble. You do need, however, to reach across the barrier and become familiar with some conventions, some jargon, because it's not going to be packaged up for you with a nice little ribbon. One of those things you're just going to have to adapt is to not use Microsoft Internet Explorer. Not very many astronomers use Windows. Most of them are using Mac or Linux machines. So the archives, which don't have a lot of money, don't have the resources to support a browser that basically nobody in their primary audience uses. So go get Chrome, go get Firefox. Don't use Internet Explorer. Some NASA archives sorted by center are listed here. So IPAC is at Caltech in Pasadena, where I work. There are several archives at IPAC. Irsa is NASA's Infrared and Submillimeter Archive. NED is the NASA Extragalactic Database. The NASA Exoplanet Archive. COA is the Keck Observatory Archive. That maintains Keck data taken under the auspices of NASA. STSCI in Baltimore, Maryland, has MAST, the Mikulski Archive for Space Telescopes. They keep ultraviolet, optical, and IR data. The Goddard Space Flight Center in Greenbelt, Maryland, houses HEOSARC, which is the High Energy and Cosmic Microwave Background Archive for NASA. The Smithsonian Astrophysical Observatory at the Center for Astrophysics in Cambridge, Massachusetts, maintains ADS, the Astrophysical Data System, which is all the literature from the 1600s through this morning, all searchable and accessible. The Chandra X-ray Telescope Archive is also based at CFA. Irsa's charter is to provide the interface to all NASA infrared and submillimeter datasets that run from about 1 micron to about 1 centimeter. It was founded in 1993. It was the original home to the IRAS data obtained in 1983. More than 10% of all refereed journal articles published today use data that ultimately came from Irsa. We have nearly 5 petabytes of images and more than 240 terabytes in databases right now, and it's growing all the time. We have all-sky coverage in 24 different bands. Many of the Irsa tools have a similar look and feel. They're using a piece of software called Firefly that provides a way to make interactive tables, plots, images, and overlays. So this is an example of what one Irsa tool looks like. I've got a catalog in the upper right. It's overlaid on an image in the upper left. And there's a plot at the bottom that is not just single columns from the catalog, but manipulations of the columns from the catalog. And it's all interlinked. So that if I click on a point in the plot, it's highlighted in the catalog and on the image. So I'm going to show you some live demonstrations of some of Irsa tools, but let me issue some challenges. For your favorite object, what is bright and what is faint in each wavelength that you can get through Irsa tools? Is it the same things that are bright in each one? You can go get a Messier object of each broad type, such as nebula, globular cluster, galaxy, and see what it looks like across the wavelengths that you can find. You may need to request different sizes of the images for different types of objects. Which Messier objects look different and which look the same across visible and infrared bands. You can also find images of something that you took with your own telescope. If it's got WCS, the astrometry attached, you can make a 3-color image with your image as one of the color planes. But like I say, in order to do that, the astrometry in your FITS header must be good. So you should try astrometry.net, not astronomy.net, but astrometry.net to fix your header. Also, Irsa's YouTube feed has several movies, both on Finder Chart, which I'm going to show you today, as well as other tools at Irsa. This is Irsa's homepage. I'm going to recommend that as a new user, you start with Finder Chart right here, because Finder Chart is the quickest and easiest way to access multiple wavelengths of the same patch of sky. So you click on Finder Chart. It's going to ask then for a position. You can put in a name or a coordinate in any of a number of units. I'm going to put in M101, and it's going to resolve it into the coordinates. Then you can ask for an image size. I'm going to ask for 8 arc minutes. I can pick which surveys I want. DSS is the Palomar Observatory Sky Survey, digitized sky survey plates. SDSS is the Sloan Digital Sky Survey. Those are both optical. We've got 2MASS, the 2-micron all-sky survey, which is near infrared. WISE, the Wide Field Infrared Survey Explorer, which is the whole sky at mid-infrared. Spitzer, the Spitzer Enhanced Imaging Products, which is not the whole sky, but most famous objects are in there. And then Akari, which is a Japanese long wavelength mission, and IRAS, which was the first all-sky infrared survey. I'm going to ask it for Akari and IRAS because I want to show you how much lower spatial resolution those missions are. Initially, I'm going to turn off catalogs because it can be overwhelming. Search. So it's coming back with all the images that it found. If you would like it to create a 3-color image for you, if you click on this icon here, it will create a 3-color image at the end of each row with images taken from that row. Here we've got the DSS, the Palomar images, the Sloan Digital Sky Survey optical images, 2MASS. Now the 2MASS tiles that Finder Chart interacts with are often very small, and so it's not uncommon to find the edge of a tile like this. Then there's WISE, Spitzer SEIP, then Akari and IRAS. You can see what I mean about lower spatial resolution. They're longer wavelengths, but they're also lower spatial resolution. You just can't see as much detail. You can interact with these images, they are FITS images. So this toolbox up here allows you to interact with them. You can do all sorts of things. You can rotate them, change the color table, change the color stretch, measure distances between objects and on the image. Let's go back because I want to show you what happens when you search on catalogs. So let's go this time to M16. Let's ask again for 8 arc minutes. We don't have to get PAS or Akari or IRAS, but this time, yes, search the catalogs within the image boundary. Search. You can see why I'm saying that this might be overwhelming if you're new at this. It has the 2MASS catalog overlaid on the 2MASS images. It has the Spitzer catalog overlaid on the Spitzer images and the WISE catalog overlaid on the WISE images. So yeah, it can be overwhelming, but it's interactive. So if you want to see the photometric measurements for that source, click on the source in the image and it's highlighted in the catalog as long as you have that tab in the foreground. That's the source I just clicked on. You can also change what's plotted. For example, the columns in WISE include the photometric magnitude. So WISE 1 M Pro minus WISE 2 M Pro is WISE 1 minus WISE 2. WISE 3 M Pro minus WISE 4 M Pro is going to give you a color diagram. So there you see, there's the plot, and it's still interactive. You want to see which source is this red source? Click on it here. It's highlighted in the catalog and on the image. There are lots of other tools at Irsa that you might be interested in playing with. Irsa Viewer is going to look a lot like Finder Chart. but it's going to give you access to a lot more data sets than Find a Chart has. It's got the positions and sizes just like Find a Chart, but then it has a huge number of data sets here. I would highly recommend that you use the filters on the left to limit what you see on the right. So for example, if you limit it to just 2 mass, you can see that 2 mass 6-degree mosaics, in other words, bigger tiles than what Find a Chart is accessing, can be obtained through Irsa Viewer. Also on the Irsa homepage is the catalog search tool that gives you direct access to many different catalogs held here at Irsa. If you write your own code, you may be interested in the Application Programming Interface, or API, to all of Irsa's holdings. You can write code in Python to get whatever images and catalogs you want. Don't forget there's lots of video tutorials available at the Irsa YouTube feed.